My name is Luke Stark, and I work at a company in Natick called MathWorks. I am here to talk about test-driven and behavior-driven development. And if they gave out handicap stickers for not being able to use PowerPoint, I'd have one. I like wikis, so I tend to do all my presentations in them, and they tend to be text-heavy, and they're out on the net at leptorx.org. You can find it. It's just a wiki search for test-driven. You'll find it. So if you want to follow along, you can.
I'll put it up on the site or link.
Sure. This presentation is really was an hour-long presentation for the MathWorks, for some developers at MathWorks, an attempt to evangelize test-driven development, behavior-driven development. I am not an expert. This is really just a story about my experiences with it. I had a fantastic experience with it, and I'd like to share it. So there is no way, as it says, that I can do this in 45 minutes. I'm going to try and do it in half an hour and leave out a few things when we get to them. So real quick before we jump in, is anyone here doing agile development? A couple. Is anyone here doing or done XP? No?
A while ago.
A couple? Only a while ago? Is anyone doing what they call test-first development currently? Few more. Okay. So I'll give you a little quick bit, a little bit of background. Test-driven development, this is arguable, has been around for a very long time. Test-first development. Test-driven development is a core part of extreme programming. It's an agile methodology. It's one of the few pieces of extreme programming that you can pull out of extreme programming and use by itself, and it'll still work. Most of the things in there don't work if you don't drink the whole Kool-Aid. But test-driven development is a programming methodology. It's based on evolutionary approach to software design and development. And Tom's getting an update. You mind if I quit, Tom?
Yeah.
Come on, let's reboot.
Like his machine.
Basically, it prompts programmers to focus on problems to be solved and to write tests prior to actually writing their main program code. Okay? And that's kind of fluffy. But let's look at an example of what's not TDD, something I'm sure a lot of us have done. Okay? So we are all familiar with the software development process, right? It starts with a feature request, drives some use cases, which then drives maybe a requirement stock, which could drive a specification, and eventually gets to code, right? So Joe Coder gets a spec. The spec may be vague. We've all experienced that. It might be clear, it might be non-existent, right? It really doesn't matter. So Joe and his team, they start coding. They're using some development methodology, waterfall, whatever, Ripple. They write lots of great code. They write some unit tests. They write some docs. They write some integration tests, right? So what did they deliver? So they delivered some percentage of the vision of what that thing was they're building. Anywhere from 0, if the project failed, to 99%. I've never seen it 100%. So now of what they delivered, what were the important features? What were the important bits? And how do they know that the things they delivered were the important parts, and can they prove it? And finally, do the tests that were written verify what it is that they wrote, or do they validate what it does, or do they validate what it should do? I'm sure you guys have seen unit tests that pass, but they don't actually test what needs to be tested, right? So this, let's say this is waterfall. This works, okay? I'm not here to bash non-TD development. This works. Software is delivered this way all the time. Successful stuff. Multi-million-dollar companies do this all the time. But it's not TDD. So let's take a second pass. Okay? So if test-driven development is a software development technique that involves basically repeatedly writing a test case and then implementing code to meet that case. Okay? It's really a design technique. It's not a test technique. So let's take the same example, but look at it sort of TDD. We've got the same case. You've got feature requests, use cases, requirement stock, specification. We start coding. Okay? So Joe gets a spec, same case. Vague, clear, it doesn't matter. They start coding. So this is a really sort of vaguely pseudo-coded TDD loop. They say, is the program or class or widget or whatever it is we're building, is it incomplete? If it is, you add a single test that exercises something that the code has to do. Okay? Then you go code. You code and code it until that test passes, right? Or you go code until you think it's going to pass. Then you run your tests. Now, when you execute, if it's first time through, you've only got the one test, but as you iterate through this process, they're going to accumulate, and each time you run them all, make sure they all pass. If it's broken, you go back to coding. If it passes, you start over at the top. Is my program complete? Eventually, you're going to say, yeah, it's done. So then you refactor. Because this sort of methodology, you end up with a lot of duplicate code. That's okay. So we all know how to refactor, right? So. Now, there's some big differences, and the business people like these differences. So they delivered some percentage of the vision, same as the first case, right? But before they got into each functional bit of code, right, they had to clarify and understand what the vision was. Because you can't express a test unless you fully understand what you're going to be testing, right? And of what they delivered, what was the important bits? They're much closer to proving it, because that clarification for the first part forces an understanding of all what's important. It forces an understanding all the way back up through the rest of the project team. So, how many people have been on a team where you know what's going on, but the animal's buggy doesn't have a clue? Nobody's gonna write. There's one. Okay. So, it's not like that at MathWorks. And basically, do the written tests verify what it is, what it does, or what it should do? Well, since the tests were written first and they were clarified, in the code for test the code is only written as far as passing the test. There's real high confidence in your tests. As these tests sort of accumulate in this methodology, you feel better, just you and the analysts, the whole organization feels better, feels much more confident in your tests. I mean, have you guys, I've been in a case where we have amazing test coverage, amazing code coverage, 90%, and the tests were, passing, but the product still didn't work. So this methodology really increases confidence that your tests are testing what they should be. So now, this is a Ruby group. When I gave this, I was preaching to a lot of Java developers. So if there are any Java developers in the audience, if you ever go here, there's a great link to a handout on how to do TDD with JUnit and Eclipse. So if you need to evangelize to Java developers, this presentation's out there. So let me tell you about my experience. So I had a little widget I needed to do. We're starting to use Ruby and Rails at the MathWorks, and we're doing a lot of service-oriented architecture stuff. And I had some services that were being published, and I needed to make sure that my code would integrate with them. I had to write some integration tests. Now, I had been reading about test-driven development. I was like, I needed a small project to try it with. It seemed good. It's just me. So I gave it a whirl. And some really strange things happened. In the first half hour, I hated it. I absolutely hated it. Test-driven development feels wrong when you're doing it. When you first start to code, and you're like, if you're really holding true to form, you write a test that you think is useless. It's like, well, I know what the app should do. I should be able to write a slew of tests right off the bat, right? But you're not supposed to do that. You're supposed to pick one small piece of functionality, one small piece, and just write a test for that. This thing should return true. Test for true. Stop. Now, test. Code, run the test, it passes, do the next piece. So, I was really not having a good time. It felt very strange, but I kept at it. I'll tell you what I was doing. I was running a tutorial. I'll tell you which one in a bit. But as more and more tests started to develop, to accumulate, an interesting thing happened. I started looking at my code, and it felt different. It wasn't the code that I would have written if I just sat down to code up this interface. I mean, I knew how to do it. I could have banged it out in an hour, right? With no tests. But over the course of the afternoon, as I was working on this, the code that came out of this was more elegant, was very, very concise, and was completely different than I would have written it normally. So something was going on there. And when I was done, it was like this gleaming thing of beauty. I had to go show it to people and doing this presentation. So in my research, they've got this thing that is essentially the learning and adoption cycle for TDD. And this is also for BDD. We'll get to that in a minute. So it goes like this. The developer starts writing tests with their code, and they use a framework, right? And as the body of the tests increase, the developer begins to enjoy this sense of confidence. I went through that. I actually found this list after I went through it, so it was like, oh my God. So at some point, the developer has this insight, or someone more experienced shows them that writing tests before writing code helps them focus on writing the code that they need. So these first 3 bullet points is pretty much TDD to a core. If you want to say, I do test-driven development, you can do these 3 things and be perfectly valid. Okay? Now, as you go further, the developer notices that when they go back to the code, and this is absolutely true with me, the tests themselves end up being documentation for what it does. The point of revelation, and it really was the point of revelation, is when you realize that, oh my God, my tests have helped me do design on my app. So it's not, you may have a spec you're writing to, but chances are your spec has some vague points, or maybe it's in blocks or whatever. Writing these tests first is going to give you ammunition to go back to your analyst or whoever, your team lead, and say, hey, this part of the spec is vague, and here's the test that proves it. I can't write a test that exercises this because it's too vague. So it really forces communication. It's a great thing. And then finally, as you start to get expertise in TDD, and I don't have expertise, but I'm hoping one day I'll get there. You get to the point where the developer realizes that TDD is not about testing, it's about behavior. So we're going to flip over from TDD to BDD. We'll say this right out. Behavior-driven development is test-driven development. It's just done really well. If you're doing BDD, you're also doing TDD. You're just doing a really good job of it. So the problem with TDD is that people focus on tests. So the point of BDD was to allow us to get through that list and jump past 1, 2, 3, get past the test-driven stuff, and get to the real meat of it, points 4, 5, and 6, and a few others. I didn't list them all. It's sort of faster. BDD is sort of like a shortcut to getting to test-driven, it's a shortcut to get to a better designed place. So essentially, BDD relies on using a really small vocabulary to minimize miscommunications, ensure that the business, the developers, the analysts, the testers, the managers, they all use the same words. Right? Test means different things to different people. So these are just some examples. There isn't a hard and fast set of words. There's a couple different BDD methodologies published by different guys who want you to buy their books, do all that stuff, and they all like their particular flavor. As long as you're consistent and you pick one that works with your organization, you'll be fine. Some examples are like, business user works with analysts to write stories. Right? Stories are in the form of, as a role, I want feature, so that benefit. And benefit's important. As a developer, I thought benefits were annoying. Because it's like, why do I care why the company wants this? They just want it, let me implement it. But it's really important for developers to understand what the benefit of the features are they're implementing. Because developers aren't stupid. They can catch things that analysts and use cases miss, right? It's important to know that benefit. So you could say, hey, red flag, this thing, this use case, it's bogus, right? And let's see, a couple of things. Developers write specifications to describe and validate behaviors in their code. So BDD isn't about writing tests. It's about saying, what should my code do? What is the behavior of this piece? Turning your brain around for that mindset is hard at the beginning. It's not fun. It feels very strange. When you go to, if you're going to implement a little snippet of code, a little class that calls a web service, right? You know what you need to do that. I need to go get SOAP whistle driver. I need to, instantiate a whistle driver factory. You know what to do. Your brain makes assumptions for you. It makes leaps in design because you're sort of running on autopilot. You know how that stuff works. So if you do BDD, it forces you to stop, even though you know that you can write 6 tests that you know you're going to need to test for. It forcing yourself to slow down, just write one, and then go write the code for it, changes your design pattern, your mental pattern. And as you go through, you'll find yourself implementing fewer, you write less code. The code you write is more concise, you do more with less. Ruby's really, really good for this. We don't have cold hard cash, because we don't have time. But essentially it was, every time I mentioned the word test from this point on in the presentation, if someone caught me, I gave them $1. Sorry guys, I'm poor. Not gonna happen tonight. So, BDD, how to do BDD with Ruby. Here's the thing, beauty. I use RSpec, and if you guys haven't looked at RSpec, you should. If you want to do any form, TDD, BDD, RSpec is really aimed at BDD, but again, BDD is just TDD done well. So there are frameworks, right? All sorts of units, if you're in Java, JUnit, whatever. But here's an example of RSpec. This is pulled right off the RSpec site. It's basically a specification for a stack. Now, we all know what a stack does, right? So when you do BDD, you work in the terms of context and specifications. You don't write cases and tests. So you say, okay, in the context of an empty stack, this is all just plain English, right? Context of an empty stack, a stack should be empty. There's a specification. We specify it should no longer be empty after push, right? It should complain when sent a peek. An empty stack should, right? So when I started writing this, it's like an empty stack should be empty, right? So this implies, through Rails magic and introspection, Ruby magic and introspection, that there's a method on this stack object called empty. Like I would never have written stack has empty. It's like stack has, an upper bounds and it's got an add and push and pop and things like that. Those are assumptions. I know how a stack works, right? So I would normally go write those methods. You don't want to do that for this. You write a specification, should be empty. Run that test, it fails. Why? There's no empty method. No empty question mark method. So you go implement it. What does it do? It returns true. That makes no sense, right? Well, it needs to check something to see if it's empty. Not in this case. You just write an empty method that returns true. Next, you go, next specification, it should no longer be empty after push, right? This implies that there's a push method. So this specification is going to fail until I have a push method, right? And after I push, it should not be empty. So now, this specification is going to force me to say, oh, so now I have to go refactor my code a little bit, and rather than having empty just return true, I have to give it some knowledge. This is how you, through adding these specifications, you build up just what your app or your class needs to do. So, have I lost anybody? No? Okay, so let's find another context. So I won't linger here, but so once you're clear with the first context, an empty stack, you think you've got an empty stack implemented, you move to the next context, right? So say a stack which is neither empty nor full. So each of these contexts in RSpec have a setup method where you would set up your object that you're testing. So in this case, we've got an empty stack, but we want neither empty or full, so we push some things onto it. Well, we've got, by the time we get to this specification, we've got a push method. We've got all the stuff we need, and you just sort of, it's like, sort of like building Perl, right? Every layer, keep adding layers of that Perl. When you're done, you've got this beautiful thing. So let me skip beyond this here. All right, so it's there for completeness. If you go to the RSpec site, their tutorial section is excellent. You can actually take the RSpec tutorial and throw away the app that they're building as part of their tutorial and implement your own. They've done a really good job. You can actually follow their steps but build your own app. So we'll really try it. So, and for, because of time, we're not going to do a stack exercise. Everyone in this room knows how a stack works, so we don't need to specify a stack. So on that original list of the sort of behavioral map of what happens as you're learning this thing, there's actually a 7th step that involves mocks. Is anybody here comfortable with mocking, using mock objects? A couple people? It's sort of up there. I didn't know anything about it when I started. So this is good. I was writing an integration test. I needed to test that my bit of code could exercise these external services. Well, what if those services aren't there? What if they're being implemented? What if you're working in a waterfall shop where, sure, you're building your piece, but they're still working on the specification for what they're going to build. They're not even there yet. And they can't even give you the spec because they don't know, right? They're going to build it, make it beautiful, throw the spec over the fence. You don't have it yet. Well, you can use mocks. Our spec has mocking built in. I think it uses, I think it embeds like schmock or something. And these are just words I'm dropping. I don't know anything about the schmock library. I know that it's embedded in our spec, and I know it works great.
You do that and you write 50% of the time.
Exactly. So, so what you can do with mocks is, so we'll say that I need to exercise a service. I need to write a test for my integration with a service that doesn't exist yet. Well, I just write a mock object. Mocks work just like specifications do. They say, my mock should receive message, and you give it some data. You actually build up these objects, and you just define, using natural language methods, what their behavior is. Just like you're in the middle of defining what the behavior of your piece is through specification, this sort of, it's a little bit of a shortcut, but it's not, you're not actually implementing, you're just mocking up what you want. So when I send this, I should get this. And it's a good way to allow the thing you're actually building to run tests against integrations. So the really nice thing about mocks is when you're done, you can give your mocks to the people who you're waiting for their stuff from. Say, hey, great, you know, if you build to this mock, the specification to match this mock, we'll be done. That's really great. So, did you?
Yeah, I'm just wondering, like, it's not quite obvious what should receive means. Like, does it mean that the method is defined, or does it mean something more?
So all this means is that my mock is willing to receive a message, this could be any symbol, with 3 arguments. And here's some data.
And notice that, like, you can call message with those arguments on the mock?
Yes.
Okay.
So when you're writing your specification, you'll say my interface with mock. So in your setup, you instantiate a mock, and then in your next specification, in your context, you actually can exercise the message method on that mock. Yeah.
I was going to say, it's a little bit beyond that, there's stubs and mocks.
Keep going.
And stubs say that an object is willing to receive, and a mock actually ensures, I think should receive ensures the message is called with the arguments 1, 2, 3 by the end of your test.
Yes.
You could have a returns on the end of that with 1, 2, 3 and returns, you know, something or other, right? I believe you can do that. Another mock language.
Yeah, that's very true. And honestly, my mock experience is about as limited as this. So, thank you. If you have any more, please pipe up. So, like I said at the beginning, I'm still on this path. And when we get to mocks, I hope we'll share messages in Google groups or something like that. So, but let's keep going. So we've got a benefits list for TDD, and I include this so you can sell it to your analyst or your manager or whatever. So basically, some of the benefits are, so you've got a specification, the specification for BDD when you're done. If you, with RSpec, you can just run your specification and it'll output everything as text, right? So you actually got just a plain text document in plain English of what has been specified. It's a validation of correctness, right? It's not just a validation of what it did, it validates that it's correct. So you still need code reviews, you still need design reviews. BDD drives the design of the program, and starting out, your design can be vague. I know a lot of developers that are in a place where if someone hands them a vague spec, they'll dig their heels in, be like, no, I can't start yet because the spec's not done. Right? I've been in a place where I did that. I'm sure you guys have. It's like, sorry, vague, not working. Right? With BDD, you can take a vague spec and you say, all right, fine, I think this is the behavior you're describing, so let's try and make a specification for it. If you can, great, move on. If you can't, you've got ammo to take back and say, we can't get any work done. As opposed to, that way you appear to be more of a communicator and less of a stick in the mud. Doing BDD figures out the how. Well, other people argue over the what. So we've all been in situations where, okay, we're working on this integration, we know we're going to need some sort of data exchange format, and then they go on for months arguing over what the format is, right? When what you really need to be doing is figuring out how to implement the framework for doing that communication. So this will let you go work on that framework while they're still working on the what. You go work on the how. So it's a big time saver. A couple other things. You're really only concerned with the interface and not the implementation up until it matters. Your specification is really just the behavior, right? This ties in nicely to domain-driven design. Anybody's interested in that? It's a great book that I've got on my bookshelf. One day I'll read. Code is not approached through mathematical assertions, right? Doing regular, like JUnit testing, you make these mathematical assertions. Function will return 4, right? That's valid, but what is its value as opposed to having an assertion, not assertion, a specification that says this function behaves like foo, right? Very different, much more useful. And really, it's not about getting the right answer. So we've all got tests that get the right answer, but they're still not valid tests, right? It's about getting the correct behavior. And once you have correct behavior, the right answer is just a side effect of that.
I'm sorry. Can you? I don't really understand that point very well. If you have something that's supposed to return 4, the behavior BDD approach is going to still say, does it return 4? Right? I mean, I'm not sure. So can you be more specific about the distinction?
So let me think of a better example. So I know that when I call a service that gets a customer account, right? If I ask for customer account 42, I know I'll get Bob Johnson, right? That's a valid assertion. So in BDD, you're going to have that in there, but what you need to focus on before you get to that point is, I've got, when I call this method, method get account, right? Behavior is it's going to return me an account, much more vague, right? Later on, as you get more, a lower level of granularity, you are going to get to certain assertions. But by the time you get to those, it's almost a side effect. You've already defined that. Before you even get there, you're confident that I know it's returning the stuff I need it to return. I know it's behaving in the way I want it to behave. This is arguable. That's why I said we can argue. So I find it's better overall for the project team to look at it that way because it forces people to actually pay attention to what's happening as opposed to did the test pass. Right? That's why we try and get away from the word test even. It's iterative if you like to iterate, but you could do this in waterfall process too. We focus on the task at hand. Right? There's a great progression here if you do this and it all, the holy grail, right? You get less complexity, simpler code, code elegance, pride in our work, better motivation, and we win, right? Let's go for beer. And better test coverage often, this is arguable. Fewer defects, certainly, that's been proven. More trust. I've been in the unenviable position of having a head of a VP of IT who doesn't actually trust the developers to write bug-free code or low bug code. Oh, did we go to sleep? Yeah. Sorry, guys. And it just brings us closer to 0 defects. So.
It seems to me that BDD is like the object-oriented version of TDD.
Yeah,
behaviors as opposed to procedural yes, no.
Yeah, it is. It's another layer of abstraction pulling you up a little higher. And so there's a big section on further reading. All the stuff that you would find in the Google search, Wikipedia, testdriven.com, great. Behaviordriven.org, very, very good site. Go to the RSpec site as well. This is something we need to look at. Even if you're just doing test-driven development, go read James Carr's blog, especially the entry on anti-patterns. He's got a cornucopia of perfectly valid seeming tests that will bite you in the ass, or that are just, you'll have all these tests, they look great, and you'll find that they're this anti-pattern that's not actually doing what you expect it to do. So tools, RSpec, if you're in Java land, JUnit version 4 will work if you're on Java 1.5, I think. I know this is a Ruby group, but if you've got people who are Java developers you're working with and you want to get them into this, say, hey, if you're doing Java 1.5, you can use JUnit 4, which supports all this stuff. So RSpec, of course, there's some great tutorials. And what I really enjoyed was Google Video had a great presentation on BDD from the guy who wrote RSpec, whose name I can't remember. So, but that's it. That's my evangelical stuff. All right, any questions?
Yeah, I was wondering if you looked at test spec at all.
Nope.
Okay, it's a layer on top of just our unit,
Okay.
where the syntax is almost the same, like should be empty, that type of thing, ends up being split with dots. But other than that, you use context, you use specify, and then what it does is it actually translates it to a test unit underneath the covers.
Okay.
It's almost the same thing.
So post it. If
I
you
do
post that
stick on
somewhere.
Word.
Yeah. Well, yeah, we can just add. No, not
It's
right
read
now.
only.
Well, send
Yeah,
this
it's
send this link out to the list, and then you can send out your link, and we can just have a nice thread about it.
Okay, cool.
Sure. Anything else?
You mentioned the term domain-driven development. Do you know like the dictionary definition of it?
No, I've got literally. I have a book on my bookshelf
Okay.
that says domain-driven development, and I'm going to read it one day.
Okay.
But
Eric Evans, got sort of light
Yeah.
blue, about
yeah,
an inch and a half thick.
I used to chastise my pets.
Yeah. If you've made it through basic design patterns, you're kind of ready to step it up a notch. That's the sort of the
Have you had
backbone.
experience?
I've gotten through the book, but not real life experience.
So
How
you'll be
it's,
next month's speaker.
I need a bigger team to get the leverage.
Actually, domain-driven development talks a lot about a common language. They call it
Yeah.
Ubiquitous language.
Yeah.
And I think that's a big selling point for RSpec is
Yeah.
that you have English almost. You know, when you run these tests, you say you have a set of English statements.
Yeah.
That comes really close to, common language among analysts. And
If you've got people who write unit tests, they're using JUnit or whatever religiously, they've been doing it, they've been good, and they've written this stuff for a long time, they'll break on a lot of the ubiquitous language stuff because they see plain English, something that looks like natural language, and it bends their brain. It's actually harder for them to transition. So if you show this to someone and they just don't get it, just sort of keep at them, especially if they're really good with unit tests. They have to come around to it. So, yeah.
We had a sort of a debate about this actually just last week because we're pretty committed to just doing normal unit testing. But one thing that I wanted to know is, especially with the mocks, it really seems like a lot of the time you end up testing the implementation. And some things that you said just earlier about how you're specifying behavior and basically designing the application rather than writing tests maybe speaks to this. But I have a problem with, the thing that annoys me most about tests and makes me wish I was writing less tests is the fact that I'll have working code and breaking tests. And it seems like if you're specifying for some class method that it should receive, in the course of executing some other method, it should also receive these messages, or other objects should receive messages, that's testing the internal workings of that method rather than the state, rather than like just inputting something and expecting it to get something out.
I'm not following you very well. So are you talking about an integration between the pieces, or are you talking about something that relies on another class internally?
I'm not talking about a specific case, just in general, if you're specifying messages that are being received in the course of a case statement,
Okay.
then aren't you testing the implementation of your code rather than its functionality?
For example, the RSpec on Rails plugin that you can install to use RSpec with your Rails applications. It, in the controller test, mocks out the models. And when you test against the controller action, for example, the index action on one of your controllers, it does a should receive, find, given, all, and return some models, right? So that means that you're never actually hitting your active record models, and that's good because it's faster. The bad part is, what if you re-implement your index to call your own custom finder, right? You're no longer, what the RSpec test is testing is the interaction between your different models.
Right, but you've changed your implementation after.
No, but the specification was only that the index page should show 5 items, right?
Okay.
And you changed your implementation to, instead of calling find all, you changed it to say find, you just find something else, besides find all, but it still returns 5 items.
Wait, before you were calling find all, the conditions being limited to 5 and you only give it a reason. But you later realized that that's a lot of typing to do, and better to call find underscore recent and define that as a method on your active record model, right? So if you change from using that long find all to find recent, test rate.
Yeah,
Which means your tests are brittle.
But didn't you change your behavior?
No, you didn't change your behavior.
It sounds
it's
like
still returning the same
You
thing.
just refactor it.
Right.
I think that mocks are pretty much used to reduce dependencies, you know, so when you have to make an expensive call out to a web service or to a database, that you could just mock that up. And that's how I've usually used mocks, but not to, you know, actually, you know, test the, like you said, the implementation.
Yeah, we also use mocks often for, you know, like when we're dealing with going over the web or file system calls where it might be dangerous, something like that. We do use mocks. But it seems like in a lot of, and you did not actually give any examples that tickled on what we were discussing.
Right.
All of your examples are very much like test the interface and not the implementation.
Absolutely. And you may, I mean, you sound completely valid. I haven't got to the point where I've been in that case. That's something, I know you want to write less tests, but that's something that I'd be fascinated to know if you guys, on your next project, or one of the beauties of BDD and DDD is you don't have to start a new project with it. You can go start with an existing application, go write some specifications. Try writing some specs that are exercising your mocks. I'd be curious to see more concrete, like what your experiences are with it, because
Well,
I haven't been.
we've actually been doing that, and we found that it takes a little bit of finesse, but you can write tests that aren't brittle and that don't peak inside the implementation.
We came to the conclusion that, based on Tamara's internal presentation on our spec, that our spec, in theory, was good. It was only when you were verifying that find was called within your controller
Well,
that it sort of broke down.
Well, that's when you're testing the implementation.
Correct.
Yeah, I mean,
that
but
comes
the
from a
part that-
specific example.
The part that annoyed me about that was that is, when you do the rate generate with the RSpec, you do a rate generate, I think it's, I can't remember, but there's a generator that you're supposed to run that produces test files for an entire REST resource. And when you do that, the test files that are generated are full of this. We're all over there, you know, checking on those.
we'll get there.
Yeah.
Eventually,
So,
we'll
so
need
the
to
tack
know,
we're taking is actually to sort of build a helper library to make a more behavior-driven development oriented testing, but without, you know, doing verifying that find was possible.
just don't charge for it.
Yeah.
The basic question is like behavior-driven development really tied to that, to like interaction testing?
No.
Or can you do something more?
Behavior-driven development really firmly is a design tool, software design tool. It has, I mean, that was the reason they want to get rid of the word test completely. When you use BDD as a design tool, you're going to have more confidence in your tests, but it doesn't say that that's your specifications should not be your only tests.
That was the other thing that, and that is an important distinction, and explains to me, this wasn't annoying to me, but now that you say that, it makes more sense. That I couldn't just run rate and have it run my regular tests and my specs. I kind of expected the RSpec on Rails to replace my unit test framework in Rails.
Yeah.
So just run rake and run my specification.
I have not used RSpec on Rails, but that seems like to go in the opposite direction of what the actual BDD publishers are talking about. So
Yeah, that makes sense.
Yeah.
Thank you.
I'd say that what we're kind of saying here is that when you touched on the should receive method, it seems like BDD is lying to itself when it says that's behavior-driven development. Because it seems like that's specifically implementation details and not, and it's
look at it this way: it's not. So at that point, you're not doing design,
right.
You're doing. I need to get past this. It's almost like just a tool to leverage so that you can continue to do your behavioral specification for your software. But you need this piece that's not ready yet, right? So it's sort of a crutch to put you, at least give you some ground to stand on. I'm not a mock expert, but there's volumes written on it. So as far as my understanding goes, that's what I've used it for. So, anyway. All right, I'm done. Thanks.